Musk agrees that AI is now a war over electricity. Valuations will begin to reflect AI plus energy synergies. Those who can guarantee stable power supplies will command premium multiples. Chip-heavy, software-centric players without energy solutions may hit a growth ceiling. AI has evolved into a full-spectrum war across tech, energy, and industrial policy. Training and inference require immense energy. Training a GPT-class model can consume millions of kilowatt-hours. Inference at global scale is just as demanding. AI workloads now account for 10 to 20% of data center power use, cooling included. From the power draw of NVIDIA's Blackwell chips to the gigawatt-hours consumed in each training cycle, AI has become an energy-intensive industry. As of 2024, U.S. data centers consume 3 to 4% of the country's electricity. By 2030, this could hit 12%, according to projections from the IEA and EIA. AI and reindustrialization could drive nationwide demand up by 30 to 110 gigawatts, equivalent to dozens of new power plants. In regions like Arizona, Texas, and Northern Virginia, AI data centers may overwhelm local grids. Tech companies will need to secure chips, scientists, and now, energy. Google, Amazon, and Microsoft are locking in long-term energy via power purchase agreements. Google in Iowa, Amazon in Texas and Virginia. Microsoft is even exploring nuclear options. Energy has become a strategic asset, on par with patents or data warehouses. Within 5 years, control over electricity could define who controls AI. Before 2024, leadership was about who had the best model. From 2025 onward, it's about who owns the infrastructure. A new competitive framework has emerged, 5 dimensions: model innovation, user ecosystem, capital strength, energy access, and vertical supply chain integration. Musk now spans all 5: XAI, compute, energy, storage, edge devices, autopilot, and Optimus. He's aligned across the entire stack. Meanwhile, OpenAI is evolving from a language model innovator into an infrastructure sovereign. Its energy deal with Oracle is the largest AI-related power agreement globally. The goal? Independence from AWS, Azure, and GCP. OpenAI is racing to control models, compute, distribution, and user behavior. If it succeeds, it could become the sovereign platform of the AI era. Unlike Palantir, which integrates AI into governments and industry systems, OpenAI is focused on being the infrastructure that others must use. Its valuation is driven by platform dominance. Palantir's $300 billion market capitalization lies elsewhere. Its role is system-level AI governance, Foundry, Gotham, AIP. These are data-driven decision platforms for defense, healthcare, and industry. Adoption takes longer, but once embedded, Palantir becomes the AIOS of its clients. Its growth is slow, but compounding, playing out over 3 to 5 years as its ecosystem hardens. Tesla represents real-world AI, not inference APIs or LLMs, but physical deployment, embedded decision loops, and end-to-end integration. Tesla monetizes AI through hardware plus subscription, from billions of driving hours to dojo training to software deployed in actual vehicles. This is edge AI at industrial scale. Its business model is underestimated because its AI impact doesn't show up as API revenue. But as full self-driving and Optimus mature, AI's marginal value lifts ASPs and margins. Tesla uses AI to increase hardware value, a model unlike anything in Silicon Valley. It owns its data, vertical stack, and deployment infrastructure. It's a closed-loop physical AI system. Most analysts overlook Tesla's AI edge because they focus on LLM benchmarks, cloud inference, and SaaS. But Tesla is arguably the most advanced viewed from the lens of real-world impact, changing transportation and manufacturing. It's fighting and mastering inference at the edge, where OpenAI, Meta, and Google have yet to win. This is the true map of the new AI age, a geopolitical, capital-intensive, power-hungry, and vertically integrated race. The next 5 years will determine who builds the best models and who controls the infrastructure of intelligence itself. On the other hand, Meta has quietly launched a nearly $30 billion AI infrastructure financing initiative. This signals a deep strategic shift, one that blends financial engineering, asset-light operations, and long-term control over AI compute. Meta and Tesla also frame the AI race as an energy and resource allocation war. Meta, Tesla, OpenAI, Palantir, and other tech players are now competing on infrastructure sovereignty. Instead of using its over $70 billion in cash or leveraging its top-tier credit rating to issue public bonds, Meta has opted for a less conventional route. It's raising funds through a mix of private credit and $3 billion in equity. Key backers include KKR and Carlyle. These investors will own the data center assets, which Meta will lease back under long-term contracts. The move keeps capital expenditure off Meta's balance sheet, preserving its return on invested capital and shielding earnings per share from depreciation pressure. Instead of building and owning, Meta is outsourcing asset construction and operation, which maximizes time and flexibility. It retains control over the deployment of AI models while avoiding the time and policy delays tied to internal budgeting, land acquisition, and energy permitting. Meta is replicating the telecom industry's classic build-operate-transfer model, an approach rare in Silicon Valley. Meta's capital is going into two high-stakes fronts: a 2-gigawatt build-out of new data center infrastructure. That level of power could serve hundreds of thousands of homes or a mid-sized city, signaling that Meta sees AI infrastructure as a public utility in waiting. Second is GPU procurement. Meta plans to deploy over 1.3 million GPUs, an investment also exceeding $30 billion by 2025. This is the backbone for inference, generation, advertising, and personalization across Meta's ecosystem. Unlike Microsoft and Amazon, which are scaling up Azure and AWS, Meta is building for itself. Llama runs on Meta-owned centers, embedded across Reels, WhatsApp, and Threads. This gives Meta tighter control over cost, latency, and integration. It's choosing vertical integration over SaaS monetization. From a capital markets perspective, the financing structure marks a new era. AI infrastructure is now being treated like power plants, ports, and highways, long-term, yield-generating, and protected by regulation. For institutional investors, AI compute is becoming an asset class, with steady leases, defined cash flows, and leverageable structures. The commoditization of compute means GPU clusters are becoming tradable assets. But there are risks. The AI hardware cycle moves fast. In 2 years, new GPUs could double performance, making today's $30 billion deployments obsolete or not as valuable. Then long leases become shared liabilities. And as AI-driven power usage surges, regulators may start taxing or capping energy consumption, dampening long-term returns. Meta is crafting a capital strategy tailored for the AI era. The competitive moat has shifted from model quality to infrastructure ownership. The new battleground is who controls land, power, and compute density. Meta is using financial structuring to create its own version of digital sovereignty.